So in the last class we have started our discussion on file system architecture, and we have seen that the architecture of the file system can be placed like this. On one end of the file system we have the user program which puts requests for accessing defined files, either for read operation or for write operation or for modification, updation and all those things. And at the other end we have the devices which contains the files. Okay. So we have different layers in this architecture. At the lowest layer, that is the device driver. The device driver is an interface with the devices. I mean, it is the device drivers, which is nothing but a set of softwares which directly controls the devices that contains the file. Just above this device driver, we have another layer which is basic file system. And we have seen in the last class that the main responsibility of the basic file system is to initiate an IO operation and then processing the completion of the IO operation. That is, whenever a process puts some request for reading a particular block of a file, the basic file system will instruct the device driver to read that particular block. And when the block is read, then the device driver has to generate an interrupt by which the IO operation can be terminated. This basic file system, it mainly deals with the blocks. It does not understand what is the content of the block. So what it does is it simply takes a block from the device and puts that into the buffer cache. Similarly, for write operation, it takes a buffer cache, content of a buffer cache, and writes that into one of the blocks in the devices, depending upon whichever is free or some block is to be updated. In that case, it has to write the block in the same block on the secondary storage. In case of basic IO supervisor, we have said that among many responsibilities, the first responsibility of the basic IO supervisor is to identify the device on which the IO operation is to be done. Okay. So in case we have a number of different file systems, so for different file systems there will be different identification numbers. So depending upon the file which resides on a particular file system, the basic IO supervisor has to identify that file system, and on that file system the IO has to be done. Okay. The other responsibility of the basic IO supervisor is the scheduling of the IO operations. So different processes may put requests for accessing different blocks in any arbitrary order. So it is the basic IO supervisor which will reorder all those requests so that the throughput of the file system can be maximized. Okay, and we have seen two examples of such scheduling, how the scheduling can be reordered, how the requests can be reordered so that to maximize the throughput of the system. Now up to this, whether it is device driver or basic file system or basic IO supervisor, all these levels, they work on blocks on the secondary storage and buffers in the main memory. Okay, so all the controls for these three levels are in the form of blocks. But whenever an application wants to modify or wants to access any data containing in some file, then the application is not really interested in the block. What the application is interested in, either in the fields or in the records. Okay, so there is another layer which deals with the records contained in a block. Okay, so that is what is called a logical IO. Okay, so it is this logical IO which allows the application programs to access different records or different fields in the block. Okay, then finally the records will be organized. I mean, different file structures can have different kind of record organization. Okay, so accordingly, at this interface level, the interface between the user programs and the file system, I have to have a set of softwares which are file structure specific. Okay, up to this we didn't consider about what is the structure of the file. I have a block, put a block in the buffer, then once I have a block in the buffer, the logical IO breaks that into a number of records and the records are passed to the user program. But for different applications, the file structure may be different. Okay. So to take care of that, so that the user need not be concerned about what is the file structure and write the program accordingly, there is another layer in the file system which takes care of the file structure. So we can have different kinds of files. One of the file structure is called a file. I'll come to what are these things. We can have a file structure which is called a file. We can have a sequential file structure. We can have an indexed sequential file structure. We can have just an indexed file structure. We can also have a file structure which are called hash files. So there are several kinds of files which can be present in a particular file system. So at this level, the level which is interface with the application programs or the user programs, I should have different functionalities to take care of different kinds of file structures. Okay, and since this is the layer which gives access to different contents of a file to the user program, this is also known as access methods. So all the routines that are put in this layer are nothing but access methods. Okay. Now all these functions can also be considered in some other way. Say for example, whenever an user program or an application program wants to access a file, it gives a command containing either the file name or the path from the root leading to that file name, file or directory. Okay. So that we also have discussed in when we have discussed about the inode structure. So the user commands as input will be either file names or the path names. Okay. So these user commands has to make use of what is called the directory structure. And we have seen specifically in case of Unix that how given a directory structure and a path name or a file name, that can be converted to an inode. Okay. So from this, and depending upon the file structure, so here what I can put is a block called file structure. Okay. So it will generate different file manipulation functions. Okay. And these file manipulation functions will obviously depend upon the access methods. Okay, because different file structures are to be accessed in a different way, and manipulation will also be different. So these different file manipulation functions, what they need is the records, not the block. Because if I want to manipulate something on the file, maybe I'll be manipulating either the field for which I have to access the record containing that field, or I may be interested in manipulating the entire record. Okay, so for this what will be needed is the records in a block of the file. Okay, so this is the user level view. An user would like to access a record or a field in the record. But when it comes to the file system, the actual physical file system, the file system is interested in the blocks. Okay, so I must have some mechanism for blocking all these records before it is placed into the placed actually onto the file system or the disk. Okay. So by this blocking mechanism, what I'll have is a number of blocks okay, and this is the block which will go onto the disk. And for placing the blocks onto the disk, what the operation needed is what is called a free storage management. Okay. So with reference to Unix operating system, we have seen all these things except the records and blocking. We have seen that given a file name or given a path name leading to a file or a directory, how to convert that into an inode. Once you have an inode, following the inode, I can identify different blocks on the file system which contains the data of that particular file corresponding to that particular inode. How to access it, that is get block, read, block read ahead, all those operations. Okay. Now what comes in between is the access methods which breaks the blocks into records and have a blocking method which combines the records into blocks, or I have to have the reverse method, that is unblocking. Once you have a block, you should be able to break that into records so that the applications can make use of it. Okay. So all the functions related to file system management can be put like this. Okay. Now coming to different file structures. As I said, that I can have different kinds of files. One of the type is file. I can have a sequential file. I have an indexed sequential file. I can have simply an indexed file. I can also have a hash file. For different types of applications, different file structures is suitable. It is not that only one file structure will be suitable for every application. So which kind of file structure should be used for what application, that depends on the application that you have. Okay. So all these file structures have certain aims. Whenever you design a file structure, decide a file structure, you have to keep in mind certain aims or objectives. So the first aim is rapid and efficient access of information for retrieval. So if you have some information stored on the file system in some file and I want to access that information, the access should be fast. It is not that after putting the request I have to wait hours of time before I get the information. Okay. So first objective in any file structure design or file organization design is rapid access for information retrieval. Okay. Then the second objective is, if I want to update a file, the updation of a file or updation of data contained in a file should not be difficult. So updation should be very easy. So the second objective should be ease of updation. But when a file is stored on the disk, updation of a file on the disk is not that an easy job. So unlike when the data is present in the main memory, I can always modify it in the main memory. I can expand the data by allocating memory and all those things. But you will see that when the file or the data is stored on the disk, updation is really a difficult task. But what we have to say is, within that difficulty, how we can manipulate, how we can find out the methods by which updation can be done easily. Then, of course, the other one is economy of storage. When I say economy of storage, that means there should not be much of redundancy in the data that you put. Because if the data is redundant, or if I put any extra information in the data file, then obviously the storage requirement is also going to be more. Okay. So our structure should be such that the storage requirement is economic. it does not consume much of storage unnecessarily. But this is a contradicting requirement. When I say that one of the aims of the file system is rapid access for information retrieval, this requires redundant information. We'll see later how. This requires redundant information, whereas other requirement says that there should not be much of redundancy in the data. So these two requirements are contradicting. Okay. Then maintenance of the file system should be very simple. Simple maintenance. Okay. And the file system should be reliable. So these are the objectives which has to be kept in mind while designing any particular file system or file architecture. Okay. So accordingly, for different applications, you will find that in some applications you have more redundancy, in some applications you have minimum redundancy. Accordingly, we have different types of file structures, and those structures are more efficient for a particular type of application. It is less efficient for some other kind of application. So as we said that we have different kinds of file structures: file, sequential file, indexed sequential file, indexed file, and hash file. Let us see each of them one by one. So firstly, let us see that what is a pile. Pile is the simplest form of file organization. Okay. It is least complicated, but it needs more amount of memory, more amount of storage. Pile is usually needed for collection of raw data before processing. So I should have provision that the way the data is entered or the way the data comes from some device, I should be able to store it in that form only. Because when you collect the data, you don't have much time for processing. But later on, what can be done is you can do some pre-processing on that data to organize the data in some structured form. Okay, so this pile kind of file structure is mainly used for data collection and storage. So because it is used for data collection, I cannot ensure that the data will always come in an organized form. Say for example, if I go to that student's record, say roll number, name, address, CGPA, and all these things, maybe somebody is entering name first, roll number next, or somebody is entering roll number first, name next. But whichever form it comes, I have to accept it and store it onto the file, store it onto the disk. But later on, I can do some processing on it to organize that data in the proper form. Okay. And the data may consist of variable number of fields or variable length records. That is, different records in the data can have different number of fields. Or it is also possible that they contain similar fields, but the fields are ordered in some arbitrary order. I mean, there is no regular ordering among the fields. Okay, so just as I said that somebody may enter name first, then roll number, somebody may enter the roll number first, then name. Okay. So whichever way it comes, it has to be stored onto the disk, and later on I should be able to access all those things and reorganize the entire data. That means I have to know that which field is what, which is not needed in case of a regular structured file, where the location of the fields are specific, size of the fields are specific, length of the record is also specific. There I need not put, say, first name, then the name of the student, or first the name roll number, then the roll number of the student. So this field name is not needed in case of regular structured files. But in case of pile, because I don't have any regular such structure, so every information or every data stored in the file must be self-describing. So if I store some roll number of some student, so what I have to do is I have to put it in the form of an ordered pair. Say roll number followed by roll number of the student. Something like this. If the next name of the student is entered, then it has to be stored as, say, name Thomas. Okay? Because unless I put it this way, because there is no regular ordering, no structured ordering among these data values, I will not be able to retrieve the data properly. So in case of file, this is a must that every data that you put on the file, the data should be self-describing. So along with the value, I have to also put the name of the field. So this is the, or along with the value of the attribute, I also have to put the name of the attribute. Then only I can find out that this is the roll number, this is not the name. Okay? So that is a disadvantage of file. However, this is needed only for data collection and storage, and later on some processing will be done on this to put them in a proper form. Right? Now what is the next regular form of file system or file architecture is what is called a sequential file. Okay. Now what is a sequential file? In case of sequential file, as we said that a file consists of a number of records, the records consists of a number of fields. So a sequential file consists of records of fixed length. That means every record will have fixed number of fields. Okay? Every field will have fixed length, right? And the locations of the fields are also specified. So as we said that if we put the student record something like this, first we put the roll number, then you put the name, then maybe you put the department, then you may put the hall of residence, then you may put the CGPA of the student. Okay. So it will have, so all the records in this file will have these many fields. For every field, how many character or what is the length of the field is specific, and what is the relative location of the fields, that is also specific. So in this case, unlike in case of file where I have to put the attribute name along with the attribute value or the field name along with the field value, in this case field name is not necessary. Because I know that first integer, or even if I put it in the form of a character string, the first string of characters which comes is the roll number. The second string of characters which comes is the name. Third string of characters is the department. Fourth string of characters is the hall of residence. Fifth string of characters is CGPA. That is known. Again, sixth string will be again roll number of the next student or the roll number field of the next record in the file. So because of this regular structuring, I don't have to specify the name of the field. I simply have to put the values of, store the values of the fields in that particular order. Okay. So this is what is the basic structure of a sequential file. In all these sequential files, there is a specific field which is called a key field. And those who are familiar with database, they know that there is a particular attribute in almost all the databases which is called a key attribute. There we can have different number of different types of keys, candidate keys, primary keys, super keys, and all those things. Similarly, when I come to the sequential file, there will be a particular field, because this field is equivalent to an attribute. So there will be a particular field which is called a key field. Okay? And all the records in the sequential file are usually put in some sequence, some order of the key fields. Maybe they will be placed in ascending order of the key values or descending order of key values or things like that. So always the records in a particular file, in case of sequential file, are placed in a particular order, either in ascending order or in descending order of the key values. So this ordering is done on the key values or key field. The advantage is whenever we want to look for the record of a particular student, so I give the roll number as a 9919102, and I want to find out what is the CGPA of that particular student after a particular semester. So if I put that in a particular order, in that case, searching of this file, searching for this particular entry, this particular record in this file will be easy. Okay. when you have done some searching algorithm, you must have seen that if you have an ordered file, then binary search is the method which gives you most optimum search. Can binary search be used in this case? It cannot be used. Because in case of binary search, it is assumed that all the records are available to you in main memory. Okay, but that is not true in case of a file. Different chunks of records put in a block can be available in different blocks. Okay, and we have seen that whenever I access something from the secondary storage, I access it in the form of a block. Okay, and the block does not contain all the records. So binary search operation cannot be very much effective on this sequential file. Okay, however, the records in this file are put in the sequential form. They are put in a particular order. So any search operation that has to be done on this sequential file has to be a sequential search. Okay. So because it has to be a sequential search, so if there are say 5,000 entries in this file, on an average I'll have to have 5,000 by 2, that is 2,500 search operations to find out a particular record in the file. Or in the worst case, I have to have 5,000 search operations to find out a particular record. Or if the record does not exist, before I say that the record does not exist, I have to have 5,000 search operations. Okay. So though this sequential file is very simple and it is easy to store on the disk, but the problem is the search is a sequential search. So an improvement over this sequential file is what is called an index sequential file. Yeah, one more thing before I go to indexed sequential file. Let us have some more discussion on sequential file only. That is the search operation that we have said. It is assuming that I have some records present in the file and I am looking for a particular record with a key value. Now, if I want to update the record or if I want to insert a new record in this file, then what will happen? If entire file is existing in the main memory, I can go for some insertion operations. That is, all the records which are below that record will be pushed down by one record location, okay, and the new record can be inserted in between. But in this case, any modification on the file, if I want to make, I have to read the block containing that record into main memory, then only I have to modify it. Okay, so you find that if I have a situation like this, that I have a number of blocks containing different records. So I have 3 blocks. Okay, and suppose this block contains 50 records. This block contains 50 records. This may be the last block, so this may contain 30 records. So that in the file, total I have 130 records. Okay? So this block is completely occupied by 50 records of that particular file. Now, if I want to insert a new record within this block, so the new record that I will insert, because the insertion also has to be done in some way so that the ordering of the key values is maintained. So if the new record that I have to push, suppose the record in this particular location that had a key value of say 100 and the next record had a key value say 110. And I want to push a new record with say key value 105. Okay, and the maximum number of records that can be placed in a block is 50 only. So both these blocks are full with the records. So what will happen in this situation? If I want to insert the new record with key value of 105, then all the records below this, that is records with key values 110 and above, they have to be pushed down. So if I push them down, then one record from this block has to be transferred to this block. This block was also full with records. I am putting a new record in this block. So one record from this block has to be transferred to this block, following the sequential nature. Now, any such modification on any of the blocks can be done only after you read the block into buffer cache, then to user space, modify it, write it back. That is the only way that you can do. So you find that how difficult it is to insert a single new record in a sequential file. It will involve a lot of I/O operations. Okay? And suppose this is the one that we are going to use in case of banking software. Say, for example, somebody is waiting in the queue to withdraw some money while the system goes for such a type of updation. Okay. So in such cases, maybe the customer has to wait in the queue for hours of time before he gets the money. So the entire purpose of going for computerized banking is lost. Okay. So this is the kind of operation that we cannot do online. This has to be done offline when there is no customer standing in the queue. So whenever we have some sequential file for any updation or for insertion of any new record, updation on the file system is not done immediately, or insertion on the file system is not done immediately. What is done is we can have a main sequential file which contains the current values or the current number of records. If there is any updation or any insertion of new records, then those records are not immediately placed in this main file. What is done is the system maintains an additional file which is called a log file or a transaction file. So this is the main file. This main file will consist of a number of blocks. Each block will consist of number of records. And this is a log file or a transaction file. Okay. So any updated information or any new record is initially placed in this log file or the transaction file. It does not go to the main file. Okay. And this is merged with the main file. These two are merged together to give you a single file, an updated main file at the end of the day. That is when it is ensured that there is no other customer standing in the queue. And you must have observed, those who are having accounts in the bank, that if you deposit 1,000 rupees today, or if you just withdraw 1,000 rupees today, what that clerk does is, he deducts the amount from your account. If I withdraw 1,000 rupees will be deducted from my account immediately. But just after withdrawal, if I update my passbook will not reflect that. Why? The passbook will give me the information of the main file, not this log file. So whatever new transaction that I have made, that goes to the log file. It does not go to the main file immediately. It is merged with the main file only at the end of the day. So next day, if I update my passbook, this transaction will be updated. This you must have observed. Okay, so the reason is this. And this is done only because if I want to make this thing online, this updation online, then the system will be very, very inefficient. Okay. Now coming to the sequential file, so one of the disadvantages of the sequential file, we have seen that all the search operation or the retrieval operation from the sequential file has to be done sequentially. So if I want to find out a record which is at the end of the file, so before coming to that particular file, I have to check all other files, all other records existing in that particular file. So to avoid this problem to some extent, what is designed is called an indexed sequential file. What is an indexed sequential file? In indexed sequential file, I have a main file which is same as the sequential file. So this is the main file. The main file will consist of a number of blocks as before, and every block will consist of a number of records. Okay. Along with the main file, you maintain another file which is called an index file. Okay. So here, along with the main file, we maintain another file which is the index file, and I'll put index file as a pyramid. I'll tell you what is the reason. So this is the main file and this is the index file. So this is called indexed. Main file is a sequential file. So that is why it is indexed sequential. So the idea is something like this. The main file will consist of a number of blocks. Every block will consist of a number of records. Records will consist of a number of fields. Out of that, one field is a key field. So a key field, value in a key field is unique for a particular record. No two records in the same file can have the same key field. That is how the key field has to be selected. So in case of student's record, because it is ensured that no two students will have the same roll number, so roll number is a key field. However, two students can have the same name, so name cannot be used as a key field because that does not uniquely identify a particular record. Okay. So in the main file, I'll have a number of records. Every record consists of a number of fields. One of the field is a key field. An indexed sequential file, an index file is also a sequential file containing two fields. One field is the key field from the main file, and the second field is a pointer. Okay. So what you do is, in case of main file, suppose there are 5,000 entries. Okay. So let me assume that there are 5,000 entries. That means there are 5,000 records. So there will be 5,000 key values. Out of these 5,000 key values, what I can do is, I will select, say, 50 key values uniformly distributed over this file. Okay. So when I make this index file, as I said, that index file is also a sequential file containing the key field and a pointer. So the key fields of the records in the index file are these 50 keys. Okay. Along with each record in this index file, I'll have a pointer. These pointers will point to main file. So it is like this, because I have got 50 key fields or 50 entries in this index file, so there will be 50 pointers. These 50 pointers will point to the corresponding entries in the main file. So something like this. And it will point to that particular record in the main file to which this key value actually belongs. Okay. So if I simply assume that there are 5,000 records and the key fields of all these records are numbered from, in the simplest case, let's just assume 1 to 5,000. Okay. Out of that, I am selecting 50 uniformly distributed over these records. So I'll have key fields, key values in this index file, which will be 100. There will be 100 numbers of key fields. Okay. So the first key value will have a value 1. Last key value will have a value 5,000. Okay. Then I'll have next key value as 100, next key value as 200, and so on. The pointer field of the first record in this index file points to, sorry, this should be placed in the reverse order. So this is 1, this is 100, this is 200, and this is 5,000. So it continues like this. The pointer field in the first record points to first record in the main field. Pointer field of the second record in index file, which is actually the 100th record in the main field, in the main file. So this pointer field of the second record in the index file will point to the 100th record in the main file. Okay. Pointer field of the last record in the index file will point to, say, 5,000th record in the main file. In this case, 5,000th record will not be of use. Okay, but still for completion, let us put that. Now, what you do is, whenever you want to look for a particular record in the main file, first you find out, and I will always search with the help of the key value, key field value. I will look for that particular key value in this index file. I'll find out a particular key value in this index file which is highest but lower than or equal to the key value that is being searched. Okay, so here you find that I have an entry for key value 100. If I want to search for a key value of 105, the next key value is 200 in the index file. So I'll take out this 100. Okay, using this pointer in the second entry of this index file, I'll come to the main file. And now, search operation for a record with key value 105 will start from this location, and it will continue till I reach the entry corresponding to the second entry in this index file. Is it okay? If I don't do this, what I have to do is I have to start from the beginning, go on searching each and every key values until and unless I come to a key value which is more than the key value that is being searched for. So I can reduce the number of search by making use of this indexing to a great extent. So if I don't go for indexing and I have 5,000 entries in this main file, in that case, on an average, I need 2,500 number of search operations without indexing. If I go for indexing, then what is the worst case search? This is having 50 entries. So to find out a particular record in the index file, I need 50 by 2, that is average of 25 search operations. So with average of 25 search operations, I can identify a particular key value in the index file which is largest but less than or equal to the key value that is being searched. Following that pointer, I come to a partition in the main file, and this partition contains 100 entries. So in this partition, in the worst case, I have to search for 100 number of entries. On an average, 50 number of entries. So average search operations that you have to perform by using this indexed operation is 25 plus 50. Whereas average number of search operations that you have to perform in case of a strictly sequential file is 2500. So you find the amount of advantage or gain in the number of search operations that you have to do. Okay? So this indexed sequential file gives tremendous advantage in the form of so far as the number of search operations is concerned. Now the reason that I have put this index file as a pyramid is like this. This is the first level indexing. I can go for second level indexing. So the first level indexing is indexing on the main file. The second level indexing can be indexing on the index file itself. Okay? So here I have put 50 entries. What I can do is I can select again a number of key fields. So out of this 50, I can select only 5. Okay? Uniformly placed over these 50 records in the index file. And that those 5 key values or 5 records can become my second level index. Okay? So in the second level index, I have 5 entries. The pointers from this second level index are pointing to the first level index. From the first level index, I go to the main file. Then again what I can do is, out of these 5 entries, 5 records which I have in the second level index, I can select only 2 which I will put in the third level index. Okay? Then from the third level index, I have pointed to second level index. From second level index, I have pointers to first level index. From first level index, I have pointers to the main file. So if the file size is very, very big, in that case, this kind of multiple indexing, multi-layer indexing will reduce the number of search operations to a great extent. Okay? Now we'll talk about the other file systems in the next. next class.